Today we're going to talk about stoichiometry. And stoichiometry is where we are determining the quantities of material consumed or produced in a chemical reaction. Or in other words, stoichiometry is just a big word saying that we're going to be doing unit conversions for chemical reactions. Now when we're dealing with chemical reactions, oftentimes we're going to be using something called the mole. Now the mole is the same frame of speech as that of a dozen. So if we say we have a dozen, that means we have 12. Or if we have a dozen eggs, we have 12 eggs. Or a dozen cats, we have 12 cats. We can even go on to say that if we have a dozen months, we have 12 months, or we can say we have a year. And all these are equalities. So if we have 12 eggs, we know we have a dozen eggs. And these equalities can be used in essentially doing what are called unit conversions or dimensional analysis. And so for equalities, the main premise is you have two things that are set equal to each other. If you divide them by one another, that is equal to 1. So if we have 1 divided by 1, that will give us 1. If we have 12 divided by 12, that will also give us 1. And as one would imagine, if we have a dozen divided by a dozen, we get 1. And now we can get to the example we had earlier where if we have a dozen eggs and we divide that by 12 eggs, since they are the same thing, that equals 1. And because it's equal to 1, this makes it so it doesn't really matter what is the denominator and what is the numerator. So we can actually flip that around and say we have 12 eggs divided by a dozen eggs, and we still get 1. And because all of these are equalities, they're all equal to 1, this allows us to use them in other mathematical functions. Because anything multiplied by 1 is itself. And so we can take this property and use this for essentially changing what the units are. So for an example, let's say we bought 4 dozen eggs and want to make egg sandwiches that require which each require 2 eggs to make. How many sandwiches can we make? So the first thing we're going to do is we're going to start off with our variable here that we're given here. So we have this 4 dozen eggs. And we're going to go ahead and use this row row cross method and use this for unit conversion. I found that many people find this useful. And so basically we just start off with our given variable, and then to the diagonal down of this, we need to put another equality here that has that same unit, the same unit of dozens of eggs. And so the only thing we know that is dozens of eggs is that same example we were using earlier, where we have 1 dozen of eggs is equal to 12 eggs. And the idea here is that whatever we have on top, we're going to divide by the bottom. So we have a dozen eggs here divided by the same unit of dozen of eggs. Those units will cancel out, and now we'll be left with just units of eggs. So if we do 4 times 12, that'll give us 48 eggs. But that's not really what we're looking for here, so we're going to continue on. So we can add on another little bracket here, and now I want to change our eggs into something else. And within the question it said for every 2 eggs we make a sandwich. So I'm going to put 2 eggs on the bottom here, and that is going to be equal to 1 sandwich. So for every 2 eggs we get 1 sandwich. Now if I'm looking at my units, we have dozens of eggs canceled out still. Our eggs are now canceled out, and we'll be left in units of sandwiches. So if we multiply everything on top, this 4 times 12 times 1, and divide by everything on bottom, so we'll divide by 1 and then we'll divide by 2, that will leave us with our answer of 24 sandwiches. And so this is essentially how unit conversions work, or dimension analysis works. Now for stoichiometry, we're normally dealing with chemical species. So let's look at an example with a little bit more chemical focus. So if we want to determine how many milligrams of sodium there are in 1 gram of table salt, or sodium chloride, we can go through and solve this. Now, one of the first things I would recommend doing is that you want to look at your periodic table and probably find the molar masses. So we want to find the molar mass of sodium chloride. So we're going to be looking at sodium here with a atomic mass of 22.99 and chlorine here with an atomic mass of 35.45. So let's go ahead and take a look at this. So we have our sodium contributing 22.99 grams per mole, and then we're going to be adding that to our chlorine, which is 35.45 grams per mole. We're going to add those together, and then for sodium chloride, that'll give us 58.44 grams per mole. And this is normally a very good go-to for you. If you ever get stuck, molar mass is normally a good route to go. So to answer this, we're going to go ahead and start off with the thing that was given to us, this 1 gram of table salt or 1 gram of sodium chloride. So I'm going to go ahead and start my row across method of 1.00 grams of sodium chloride. And then I need to figure out what I'm going to put on the bottom, and so we need to look for some sort of unit or some sort of quality that has grams of sodium chloride, and we need to put that in the lower section here. Now, the only thing we have is this molar mass we just figured out. So that's going to be 58.44 grams of sodium chloride for every 1 mole of sodium chloride. So now we've gotten our answer into moles. And once you get to moles, this is when you can start using a chemical reaction. Now, we didn't have a chemical reaction given to us, but we can quickly derive one here. We can say that sodium chloride, if we were able to break it apart, we could get 1 mole sodium plus 1 mole of chlorine. And we can just now essentially apply this chemical equation into our row to across method. So we're in units of 1 mole of sodium chloride right now, and so we need to put moles of sodium chloride down here on the bottom. So for every 1 mole of sodium chloride, or 1 mole of sodium chloride, we're going to have 1 mole of sodium. And since we don't have any coefficients written, it's assumed to be 1. So we're going to have 1 mole of sodium. So now that we're in our desired species, we're looking for milligrams of sodium, now we're in sodium, we can try to work to get to our desired unit. Now, in this case, we don't have any direct conversion from moles of sodium to milligrams of sodium, but we do still have our atomic mass here. So we're going to say for every 1 mole of sodium, we have 22.99 grams of sodium. And so when we get to this point, we are essentially almost done, except that we need to add in one more thing. We need to go from grams to milligrams. And so to do this, we can just add on one more conversion. I'm going to go down here to the bottom just a little bit so we're out of that periodic table. And we can say for every 1 gram of sodium, that is equal to 1,000 milligrams of sodium. And now we can multiply everything on top. So we can do our 1.00 grams of sodium, multiply by 1 mole of sodium chloride, 1 mole of sodium, 22.99 grams of sodium, and 1,000 milligrams of sodium. and then divide by everything at the bottom. 58.44 grams, 1 mole, 1 mole, and 1 gram. And if we do all that, we'll end up with 393.4 milligrams of sodium. And one thing we may want to go ahead and pay attention to is our significant figures. On the one that was given to us, we are good down to the second zero here, so we have 3 significant figures. On the second value here from our periodic table, for this given periodic table, we only have 4 significant figures. For this mole-to-mole conversion, that's an exact quantity, so that's not going to limit us at all. Then we have another periodic table entrance, where with this periodic table we're limited to down here to the hundredths digit, so 4 significant figures. And then finally we have another equality here, which is exact, so 1 gram is exactly 1,000 milligrams of sodium, so that's not going to limit us on our significant figures. So since we have 3 significant figures, 4 significant figures, and 4 significant figures, whenever you do multiplication and division, you're limited by the one that is the least value here. So we're going to be limited to 3 significant figures, so we can count 1, 2, 3. So we're good down to this second 3, or the ones digit. And so for this, our final answer will be 393 milligrams of sodium. All right. So one thing to kind of keep in mind here is we can generalize this a little bit to work for most stoichiometry problems. What you want to initially do is you always want to convert to moles. Because normally for stoichiometry, you're converting from one element to another element, or one molecule to another molecule. And the only way you can do that is by using a chemical equation. And you can't use a chemical equation until you have converted to moles. So once we convert to moles, we can use our chemical equation. And this is where we're going to apply our mole-to-mole ratio. And using this is how we essentially convert from one element or compound to another. And then the final step here is just converting to your desired units, whatever the question asks for. So you want to convert to your desired units. And this is basically how stoichiometry works. So hopefully you found this useful, and I will see you on the next video.